Hi, welcome to the third video on Introduction to Physics-Informed Neural Network. In this video, we shall see how to write a PyTorch code for the curve fitting any function. So here we will be considering the function y is equal to x square. It can be extendable to any function. The last video we saw a neural network form that if we use a two neurons and two layers, the neural network function looks similar to this one. So let's start the program. So let's see how to write the code. So these are the basic PyTorch libraries. The first one is the import torch. This will take care of all the basic operations like tensor operations and autograd. Those autograd is used for in backpropagation. The torch.nn has all the modules for the forward model. Forward models means so whenever we make a neural network, we have layers, bias, weight, and those information. So this will make our job literally more simple. Otherwise, we have to write our own function for activation function, network, those stuffs. So this will make our job easy. The third library is torch.optim. So this library has all the optimization libraries. The last library is the standard matplotlib used to plot any functions. Our first step is to populate that input features. In our case, the input feature is x. So we have generated points between 0 to 1, which has 100 points. And please note that we have used the reshape -1 to 1. So why we are using this is whenever we just use a linspace, that will generate an array of dimension 100. So we should convert that into column matrix, and our number of input features is 1. That's what we are doing here. So this will make the matrix of size 100 comma 1. So this 1 represents number of features. So this is very important. Sometimes you may feel this is correct, but because of the dimension issue, you may have some problem in your code. So this is the target function, which is y is equal to y is equal to x squared. Now we shall move to the neural network part. So in general, we define the neural network in a class because it's quite easy, because if we define a neural network within the class, that will increase the portability of the code. That's why we use it. Anyway, I'm not going deep into class and those things. There are a lot of YouTube tutorial available. You may go through. If you want some more details about class and those things, I will make a separate video in future. So you can notice this class is our class name is simple nn, which takes argument nn.module. So that means our class that is simple nn is a child class and nn module is a parent class. So nn module has all the functionalities required to make a neural network, like basis, uh, activation function, etc. Next, move to the next part of the code where we have init function. So what is init function does is this will create a constructor for the base class whenever we initialize the class. So you notice that we are not explicitly defining nn module here. Or if you want some separate video how this every function or why we are having this init and why we are using superclass and those things, please drop in the comment. I will make a separate video for that. Then we are having, instance of the class is nothing. Maybe I would say the variable used to call the class. So here we are using model is equal to this one. So when to call this class, we call it by this variable model. So at that time that will initialize these modules. Initialize the module when the module has a lot of functionalities like linear and activation functions and those kind of things. Now we shall move to the next part of the code. So this is where we define the neural network. Here nn.sequential. So it says our module is sequential. That means it will go from one layer, another layer like that. So initially we have an input feature. What here we have 1 comma 10. That means we have 10 neurons in the first layer. Similarly, we have 10 neurons in the second layer. Please don't confuse. 10 comma 10 doesn't mean we have here 10 layers, 10 layers here. So we have only one layer where we have 10 neurons and we have an output layer. So please ensure that this size is same as this size and this size is same as this size. Otherwise, we'll be having dimensional mismatch error because so after that we have written the whole neural network in the forward function so that we can call this whole function through this forward command, a forward name function name. So this is just an instance of the class. Then we have then we are defining this mean square error to the variable criteria. So just to make our notation a little bit simple, here we are evaluating the loss through mean square error. Mean square error is nothing, we already saw that in our last video. So this is the definition of mean square error. So the next step is we are calculating the output of the model to the variable ypred. Then we are calculating this loss, mean square error, the difference between ypred and our target. After that our optimization algorithm needs this gradient of this loss function with respect to the parameter. That's what we are doing in here, the loss dot backward. This will calculate all the gradients of the loss function with respect to parameters, weights and bias. Then we have a optimization dot stop that will move to the next iteration. Please note that we are using the optimizer.zero grid at the top. That will ensure we are cleaning all the gradient. Otherwise, if we put everything in the loop, that will stack up. So here just we are printing the losses every 100 iterations so that we can monitor whether the losses are converging or diverging. We are storing the output of the model here. This is optional because we already came out of the loop. So if we want to evaluate inside the loop, we can put it here. This will ensure the gradients are not evaluated when we are doing these calculations. Finally, we have these plotting functions. So here we are plotting that input function. Here we are plotting the neural network function. So let's run this code. It's very simple and straightforward code. So that's all. So this is anyway it has made a good fit. Our mean square error is around order of 10 power minus 6. So in our example, we have considered only 2 neurons. So let's try that example. Try that. Just we have to change the 10 to 2. If we do it, anyway, this is also not a bad fit. So we can able to we can play on this neural network and get a how we can study how the neural network behaves. Another thing is instead of ternary, you can try different activation functions. Maybe you should try sigmoid. So you can check the PyTorch manual where you can find a list of different activation function. In the next video, we shall see how to solve a linear advection equation using neural network. We shall also see some of the limitations of solving the linear advection using standard numerical approaches, and we shall also see what are the best practice to solve the linear advection equation using uh, neural network pins. Thank you for watching.